Hello everyone, welcome to our last part of this unit. We're going to look at the last couple sections of the textbook. These are the alkyne reactions that we haven't covered yet. They're very similar to alkene reactions with the same reagents, so hopefully you'll find that they're fairly predictable. Our first one is that when an alkyne, draw me an alkyne here, this is hexyne, reacts with a halogen, okay, like chlorine. Sometimes you'll see this 1 mole above it. That means 1 molar equivalent, or 1 mole of chlorine per 1 mole of hexyne. Okay, so if I react with 1 molar equivalent, each hexyne gets 1 chlorine. So this leaves me with an alkene that has had chlorine added onto that triple bond, now making it a double bond. They're added in antipositions. Okay, now we've got a dihaloalkene. We could add a second molar equivalent of chlorine to it to make our tetrahaloalkene. Okay, so essentially we're adding 2 chlorine onto each of the carbon that were originally in the triple bond. Okay, second one, an alkyne can react to form a gem dihalide. A gem dihalide is when you have 2 halogens bonded to the same carbon. This, in a way, is has 2 gem dihalide positions. But if we wanted to just add it to a single carbon, and not both, okay, then instead of using Cl2, we use 1 molar equivalent of HCl. HCl is only going to add 1 chlorine. Okay, so very similar, except in this case, one of those carbon gets hydrogen. If we remember Markovnikov's rule, now one of those 2 carbon is less substituted than the other. Okay, so when we add a second molar equivalent of HCl, that hydrogen will be added preferentially to the less substituted carbon. Okay, so this one's going to now have 2 hydrogens on it, and this one will have 2 chlorine. Okay, so this is called a gem dihalide. All right. One of the reactions, this works with alkenes as well. We kind of skipped it earlier. But if I have double bond and I wanted to add bromine to it in the anti-Markovnikov position, we didn't learn any reactions that do that. Bromine, and this only works for bromine, it doesn't work for the other halogens. When HBr would add to this, typically the Br would add to this more substituted carbon. If I wanted to add it to the other carbon, I need to add peroxides. Peroxides actually react with, this is hydrogen peroxide, but we could use other peroxides. But it will react with HBr, creating bromine radicals that react via a different mechanism, which allows us to add the bromine to the less substituted carbon. And this works for alkenes as well. Okay, and lastly, in our last class, we talked about oxidative cleavage, where we could use MnO4 or KMnO4 or ozone to cleave alkenes to form like ketones, aldehydes, and carboxylic acids. Alkynes react similarly. So if I've got my alkyne here, and I react it with KMnO4, we use basic KMnO4 for this reaction. This is going to cleave it into 2 essentially carboxylic acids, but they will be deprotonated. Okay, so it's going to cleave straight through that triple bond, leaving us with a carboxylic acid. I want you to remember alkenes react similarly with KMnO4 if the alkene is if the carbon's a primary carbon. or rather, if the double bonded carbon is singly bonded to one other carbon. And that's what we have here. The triple bonded carbon has one other carbon neighbor besides the one in the triple bond. Okay, if we wanted to make this into an carboxylic acid, we need to protonate it. Okay, if you remember, what we could use to protonate it would simply be an acid. We just need to add H plus to that. So a lot of times this is written in a single step, where we just write first step KMnO4 basic, second step H3O plus. Okay, but here I'm writing it in 2 steps. Okay, so this is just another way to form carboxylic acids. It's done through cleaving the alkyne triple bond. Because it makes the molecule smaller, it's typically not a great synthetic pathway or step in a synthetic pathway, but it's good to know this reaction. All right, so again, hopefully these addition reactions and the oxidative cleavage kind of match what you understood about these reactions with alkenes. I would say the only thing that's different here is they are able to happen not once, but twice, because we have 2 pi bonds instead of 1. All right, let me know if you have any questions via email or on Google Classroom. Have a good one.